Okay, so we're going to look at solving trigonometric equations. Okay, now the first thing to do is you want to have a good idea about what these equations, what the graphs look like. Okay, so we'll draw the graphs of them. And for C2, you need to be able to do these questions in radians and in degrees. Okay, but you solve them in exactly the same way. So what we'll do is we'll draw the equations first, and we'll draw them in degrees, and we'll put radians on so we can see the equivalence. So the first graph I want to draw is a graph of sine x. Okay, we're going to draw the graph of sine x. So take that. It's going to go across like this. That's x, and that's sine x. Right, so Shanice, what values can it have? What does it go between? It goes up to 1, yeah, and goes down to -1, something like that. Okay, and what sort of shape does it have, this sine graph, do you know? It does something like this. It goes up like that, comes down, goes down to -1, and comes back up there. Okay, so it's a good idea to have you should be able to draw these graphs. Okay, let's just make that a little bit longer. Okay, make this a little bit shorter. Okay, so it's sort of like that shape. Do you agree? Now let's start thinking about well, the maximum it's got is 1, the minimum it's got is -1. And so let's start having a think about what angles we've got along this x-axis here. So what's this point here, do you know? 180 degrees, yeah. Okay, so this point here must be 90, I'll tell you what, let's put it above, 90 degrees. And this point here, 270. And this point here is 360. Are you happy with that? Okay, and this just keeps repeating every 360. It goes back this way into negative angles, it keeps going on and on like that. But basically the sine graph repeats every 360 degrees, it repeats. Okay, now what we're going to do is, because we've done radians as well, can we put the radians on? So what's the number of radians here at the same point? 180 there. 180 degrees is the same as how many radians? Pi. Brilliant. So this point here, this 360 would be what? 2 pi. And this point here, oh, shall we go to this one next? Pi over 2, half pi. And this one? This is 3 pi over 2, 1.5 pi. Okay. Any questions? Right, what I'm going to do then, we'll stop the video now, and I want to see if you can draw the graphs of the cosine graph and the tangent graph. Okay, so I'll give you a couple of minutes to do that. Right, so should we try and do the cosine graph then? So, girls, quiet please. Cosine graph again goes between 1 and -1, but it's got a slightly different shape. What does this one look like? This one starts at 1. Okay, let me try and line it up with the one above so it sort of makes sense. Starts at 1. It comes down and cuts at 0 here, then it goes down, comes up, cuts here, and then goes up like that. Okay, and again we'll put the angles on. So when the angle's 180, cos of 180 is -1, cos of 0 is 1, we can see there. This is 90 degrees again, this is 270, this is 360 over here. And again I'll put the radians on. This is going to be pi, this is pi over 2, this is 3 pi over 2, and that's going to be 2 pi. Are you happy with that? Okay, so you need to be able to basically draw these out. Okay, now the last one is the tan graph is slightly different. Okay, now before I draw it, there's two other things. We're going to be solving trig equations in a moment, so we're going to do maybe 3 questions of different difficulties. And to solve them, you need a good idea of what the graphs look like. but you also need, in some cases, a couple of identities. Okay, so I'm going to put the identities up on the right now, just before we do the tan graph. And the first identity you should try and remember is that tan x. Can you remember what this identity is? Tan x equals sine x over cos x. Okay, so that's like a fact that you should be able to remember. It's called a trigonometric identity. So whenever you see a tan x, if you need to, you can swap it for a sine x over cos x. Can you put the phone away, please, girls? Okay, just get on with your work, please. Okay, so this identity you need to remember. Okay, now it's also how you could go about drawing this graph, because what we're saying is, if I want to draw the tan graph, it's the sine graph divided by the cosine graph. So let's see if we can draw it. I look at the sine graph, and at 0 it's got a value of 0, and then I look at the cos graph, and at 0 it's got a value of 1. So the tan graph should be 0 divided by 1. What's 0 divided by 1? 0. So the tan graph starts at 0. Okay, so I'm going to label this up tan now, and it's x up here. And then let's have a look what's happening at 90 degrees. Shall we have a look at 90 degrees? Well, at 90 degrees the sine graph is 1, and then the cos graph is 0. So it's 1 divided by 0. Now what's 1 divided by 0? You know? Error. Yeah? If you put it in your calculator, it says error. So what does that mean? It just goes off to infinity. So the tan graph does something like this. It goes up and off to infinity. So whereas the sine and the cosine graph go between 1 and -1, the tan graph can have any value. It goes up to infinity like this. Okay. Now let's have a look over here. At 100, let's just mark this on, shall we? This was 90 degrees here. And then we had pi over 2. So I'll put it on as well. Now at 180 degrees, at this point here, the sine graph is 0, and the cos graph is -1. Okay, so again it's 0 divided by -1, so the tan graph should be 0 again here. So what we get with the tan graph, if I keep going along and just working out all the places, let's come down a little bit, is it's got this sort of shape like this. And then goes up and back up to infinity there, and then comes from infinity and finishes about there. Okay, and I'll just go along and put all the points on again. Okay, so you should be able to draw those graphs, and they're going to help you to solve the questions. Okay, and then finally, before we can start solving these trig equations, there's one other identity that's worth remembering. And so, can anyone tell me what it was? Yeah. Sine squared x plus cos squared x equals 1. And that's always true as well. So you can use that as an identity. So those two things in the boxes, you need to remember, because they're useful. So if you see a sine squared x, you ever see a sine squared x and you want to get rid of it, you can always write it as 1 minus cos squared x. So basically this page we've got here, let me just move that, is the basics of all the stuff you will need to know to start solving these trig equations. You need to know what the graphs look like for sine, cosine and tan. You need to know degrees and radians equivalent, and you also need these two identities. And now you can pretty much answer any question on Core 2. We'll start with an easy one, or the easiest sort of question you could get. Which is basically, can you find for me the value of x that makes sine x equal 0.6? And I'm also going to tell you there's going to be multiple answers for this, so what you'll get given is a range to look in. I want all the answers in the range 0, x is between 0 and 2 pi. So we're working in radians for this question. Okay, so I'll just quickly show you how to go through it, or can anyone talk me through how to solve it? Well, firstly, for this question, you want to make sure your calculator is in radians. Okay, so do you know how to turn your calculator into radians? Okay, so we're going to, first of all, to find out what x is, we do this on our calculator. X equals the inverse sine function of 0.6. Okay, so I've got a calculator here. I want to put it in radians. It's in degrees at the moment, so how do I do that? Shift, setup, radians. Okay, and I'm going to do the inverse sine function, shift sine of 0.6, and it's 0.643. Okay, 0.64 we'll say. Okay, so I've just done that. I've got my answer for x, 0.64. Everyone agree with that? Okay. Now that's not the only answer. What I'm going to do now is I'm going to draw the sine graph between 0 and 2 pi. Now we've already drawn it, and I know it looks like something like that. And that's pi there, and that's 2 pi there. And this is x, and this is sine x. And this has a value of 1, and this has a value of minus 1. Okay, so we're basically saying in this question, when does x equal 0.64? Well, 0.64 is about here, and I go across, and it's given me one answer. It's told me that x equals x equals 0.6 at an angle of 0.64. Okay, so can you look at the graph and tell me where else it would have a value of 0.6? Someone talk me through how to do it. Yeah, Luke? Pi minus 0.64. So I start at pi, and just using the symmetry of the graph, I go back a distance of 0.64, and that there is the same height. Okay, so my two answers then are 0.64, which I got off the calculator, and my second answer is pi minus 0.64. So just do that on my calculator as well. Oh, that's not my calculator. Where's my calculator gone? That one. So pi. Where's pi? Where's that? Okay. Shift pi minus 0.64 was it? 2.5. Oh, turned it off again. So my answers for x then are 0.64 and 2.5. Okay, there's two values of x that will make sine of x equal 0.6 in that range. Can you see? There and there. Are there any more? No, that's it. Two answers. Okay, any questions? Okay, we'll do one. We're going to do two more questions. We're going to make the next one a little bit harder. So let's come down, do another question. This is the second sort of question you might get. Okay, this time I'm going to give you cos, 2 cos 2x equals 1.4. Okay. Right. How do I go about solving this one, first of all? Anybody? We're just going to try and solve this. So I want to know the values of x again, and this time we're going to look between 0. X is going to be between 0, and I'm going to use degrees this time, 360. Okay? Right, who can remember how to solve this sort of question? What would I do first? Yeah. Luke? Are you sure? Okay, the first thing is, get rid of this 2 in front of it. Okay? So I'm going to get rid of the 2 in front of it, and that gets me to this. Okay, that's the first thing. Any numbers on the outside of the function, those changes in the y direction, are easy to just push onto the other side. Okay, it's these changes inside the function, that 2 in front of the x, that's going to be hard. Okay, so what's the trick then? If there's a 2 in front of the x, what do I do? No one? Yeah, we make a substitution. Okay, we're going to say let u equal 2x. Okay, and we're going to say this problem for me, this cos 2x equals 0.7, is too difficult to solve. But I can solve a different problem. I can solve cos u equals 0.7 because u equals 2x. Okay, but because u equals 2x, the limits have now changed where I'm looking, because now I'm searching for a value of u, not x. And u is 2 lots of x, so x went to 360. Now I'm looking for u. It's going to go up to 720. Do you agree? So I've changed the problem slightly. I've changed it from 2x to a u, but because I'm changing it to a u, the limits have changed as well. Okay. So now I just have to find out what u is. So I just do it exactly the same way as I did in the last problem. I do it the same way as in the last problem. I do u equals cos to the minus 1 of 0.7. Okay, on my calculator. So now I've just got to find out what u is. So I do it exactly the same way, except this time I'm in degrees. So I've got to put it back into degrees. And I'm going to do inverse cos this time of 0.7. Okay. 45 degrees. 45.6 degrees, shall we say. Okay. Okay, is everyone happy with how to do that? Again, I draw the graph. But this time, I've got to draw the graph from 0 to 720. Do you agree? And it's the cosine graph. So it's going to start at here. It's going to go down 90, 180. It's going to come up. That's 360. And then I've got to do the whole thing again. I've run out. Oh, man, it's going to be like that. Okay. Okay. Something like that. And I'm going to go along and I'm just going to put these values in. That's 360 there. We're in degrees, aren't we? So that's 360. That's 720. What we got here? 180. 90. What's this? 270. What's this here? This one? 540. Is that right? Okay, fine. I'm no good at maths, right? Okay. So this is a graph of cos u. Okay. Right, so we've got one answer, 45 degrees, which is going to be 45 degrees is about here. So it says when u is 0.7, which is about that height, we get an answer of, what do we say, 45.6 degrees. Do you agree with that? That's one answer. Right, where else am I going to get an answer? This one. Where else am I going to get an answer though? Can you tell me? I've got one answer. That's 45.6 there. Here, yeah? So how do I work out what the angle is there?
Whatever it is,
Say again? Add it to 270, are you sure? Take it from 360. Okay? So can you see that distance from the top to there is the same as the distance from the top to there because it's symmetrical. Okay? So 360 take away 45.6 is another answer. Right. Where else is there going to be an answer? There's going to be one here, isn't there? There's going to be a value there. So what's that? I want that distance there, don't I? So it's 360 plus 45.6. And there's one more place, which is over here. So it's going to be 720 take away 45.6. Okay, so my values of u are 45.6, and then I've got, let's have a look, I can do it on here, 360 take away 45.6, which is 314.4. I've also got 360 plus 45.6, which is 405.6. And then what, Connor, sorry? 674.4. Okay, 4 solutions, do you agree? Okay. However, we're not quite finished, because u is something that we made up ourselves. What was u, do you remember? 2x. So we're actually saying 2x equals this. Okay. We just want x. So what do we do to all our answers? We just halve them all, okay? So I've got 45. Are you going to do this one, we can, okay? 45.6 half. What did you say? 22.8. 157.2. Yeah. 2. I think 202.8. Yeah.
What was that?
Yeah. 337.8. Brill. 0.2. Okay, sorry. 337.2. Right. Now, just a couple of things I'm going to say about that. You've got to get all your answers for u before you halve them all, okay? Make sure you get all your answers in terms of u and then change them all back. Now, it might be that, in this case, the substitution was u equals 2x. It might be that in the bracket it was x plus 10, so then you'd have to take 10 off them all, okay? But get all your answers first and then change them all. Notice, are all my answers in the range of what the original question asked? It was asking for answers in the range 0 to 360, okay? So we remember that graph that we've got there, that cos u graph, has been squashed and stretched to get these answers, right? Okay? Right, I'm going to do one more question, and that's just the hardest sort of question you'll get, and then we're going to stop and I'll leave you to do it. Because how long? We've been talking for ages, right? Okay. So we'll do one more type of question, and then we'll put this video up so you can just watch it as many times as you want. Okay. Okay, so for question 3, we're going to do this question here, which is sine squared x plus cos x plus 1 equals 0. And again, we're going to look in the range between 0 and 360. Okay, now, Shanice, like you just said, what's the problem with that question there? There's a sine and a cos, so you can only solve these things if they're all in terms of sine, or they're all in terms of cos, or they're all in terms of tan. So I've got to use an identity, and the identity we're going to use is sine squared x plus cos squared x equals 1, and that means that sine squared x is equal to 1 minus cos squared x. And so I can go to the sine squared x in this equation and change it for 1 minus cos squared x. So what I get is, swapping the sine squared x, I get 1 minus cos squared x plus cos x plus 1 is equal to 0. And then I put this all together, I've got cos squared x, minus cos squared x plus cos x plus 2 equals 0. And I times through by minus 1 just to get rid of that negative in front. I've got cos squared x minus cos x minus 2 equals 0. Okay, so we're there. Now, what type of equation is it? It's a quadratic equation. Okay, so you can see that if you just make a substitution, let u equal cos x, and then you can write this out as u squared minus u minus 2 equals 0, and then hopefully we can solve this by factorising. Okay? Sorry, Shanice. Yeah. Right, I think I factorised it. It factorises to u minus 2 and u plus 1. Is that right? Does that work? Equals 0. Which means that u equals 2 to make the first bracket 0 and u equals minus 1 to make the second bracket 0. Okay? Is everyone happy here? Nearly finished. Remember that u is something u made up. U is actually cos x. So we've actually found that cos x equals 2 and also that cos x equals minus 1. So what we're going to do now is go back to like what we did on the first question, and we find all the places on the graph where cos x equals 2, and we find all the places on the graph where cos x equals minus 1. Do you agree? Okay, so that's what you would do. Yeah, you would have to do the inverse and find where this is. Now, what I'm going to do is draw the graph, and then we'll find all the places. But I'm going to draw the graph first. Okay? And we're drawing the graph of cos x between 0 and 360. So it looks something like this. Starts at 1, comes down, goes up, and you should be able to draw these graphs pretty simply now. That's 360, that's 180, that's 90, and that's 270. And this is 1, and this is minus 1. Okay? And so we look at the graph between these regions. Now, Shanice, where on the graph does cos x equal 2? Yeah, you can try inversing it on your calculator if you want.
Oh, does it not exist?
It doesn't exist because the graph only goes between 1 and minus 1, doesn't it? So automatically, you can say, I don't have to bother with this answer here because it can never be 2. So you lose that straight away. And also, you don't really need the calculator for the second one either. When does cos x equal minus 1? When x equals 180. Right there, yeah? Okay? So the only solution to this problem in that region between 0 and 360 is when x equals 180. So I didn't even need a calculator for that question. Okay? And that's it, really. Those are the three methods. You've got one where you just solve it directly by drawing the graph, by solving it on your calculator then drawing a graph. You've got one where you have to make a substitution if there's something inside the function and solve it for a different graph and then change all the answers back. And then you've got one where you're going to have to use an identity. Okay? And in this case, it made a quadratic that you had to solve. Okay? And like the example we did before, this quadratic was easy to solve because it was factorisable, but it might be that you have to solve it using quadratic formula. And usually, well, we were lucky here in that we got two answers to try and find, but one of them disappeared. That might not always be the case. You might have to use both. Okay? Any questions then?